What's up?
How you doing?
I used to try to, when we double record, I used to try to like change my outfit slightly, but I've given up on it.
Well, I'm not in my white t-shirt today.
It's 8 p.m. We're recording a podcast. Everything's a little better late at night. You know? Do you feel that way?
Well, I quite like recording during the day, but it's Friday evening, and I've got a good weekend ahead of me.
But
so I'm certainly not
when do you
complaining.
feel like your brain is like? When do you think the truth comes out? You know, when do you see the world most clearly?
Ooh, interesting question. On the weekend, probably like a Saturday night in Yosemite.
You ever? Yeah. It's always when I always feel like no, it's a good point. I always feel like when I'm taking a good hike, you know, I feel like I zone in. It's the only time the brain really quiets down. You know,
It's worth saying though, it's probably like either at Tuolumne Meadows or something like that. By the time you get up to Cloud's Rest in Yosemite, you're at 10,000 feet, which is where you start getting a little lower on the oxygen. You know, maybe not.
really,
the
we just
clearest.
need to reduce our oxygen.
No. I think increased oxygen, but nice and outdoors, see the stars.
I see. There's probably a good compromise. That's why the DAX are so good. You ever heard of the DAX?
No. What are the DAX?
The Adirondacks.
Okay, is this a mountain range?
It's a mountain range on the
New York?
East Coast.
Yep.
Yeah, there's a bunch of peaks. They're only 4,000 feet high.
Wow.
But they're but they're really, really beautiful. They're really, really nice hikes. And I think, you know, I've been around the U.S. a bit. I've been to a couple places, and basically the places where I liked the nature the most were West Virginia. I think West Virginia is unbeatable, but then after that, I love the Adirondacks. I think it's great. I think it's a great compromise of like it's cold and it's warm and like the nature's really pretty. It's very green. California is brown. California is like green once a year and you remember what nature looks like and then it goes back to being brown. There's a reason they call it the Golden Hills. Right?
Yeah, it's true. Yeah, but then granted, you get out to somewhere like Mammoth, Yosemite, Tahoe. I was in Tahoe, actually. I'm wearing my Flume Trail bikes.
Nice.
Shout out.
Yeah.
Last week, or 2 weekends ago, my parents were in town. And so we went mountain biking.
Oh,
Had a
hell yeah.
fantastic time. We got mum on a mountain bike, an electric mountain bike. And we rode up from, have you ever heard of the Flume Trail?
I've never heard of the Flume Trail.
So magnificent. Naz, this deserves some photos. And so you go up, you start climbing from lake level, you climb up basically to a ridge line that's going along the side, and you're on a single track, not technical, but a single track, narrow, right on the edge of not too far off a cliff face, riding along about 600 meters to about 2,000 feet above lake level, looking down at the beaches. It is magnificent.
I like it. Flume Trail in Tahoe. Is there an entrance fee to that? Is it a public?
The trail itself is public, but if you rent a bike, as I did in this case, because I rented a mountain bike rather than my usual gravel, you can do it on a gravel bike. It's not too technical, but I was feeling lazy and I wanted some fatter tires.
Yeah, I'm with you. Tahoe's really nice, but it's like, okay, just like the weather. This is gonna get like way too local, but there's all these like pine, what do you call it? Pine needles on the ground, right?
Yeah.
And yeah, California, I get why people came to California, why going west was such a big deal, because California feels like unfathomably easy to navigate as, like, California is the only place where I was like, I could sleep outside every day of the year and I'd be fine. And it's
people do. Have you seen around San Francisco?
Oh yeah, no, for sure. But that's what, I mean, I think that's part of why. And like even navigating the wilderness, you're like, it feels like everything was made for humans because like pine needles are all over the ground and it's sparse. It's like, I don't even have to bushwhack.
Yeah.
I can just like walk through the woods. It's like no big deal. I think that's why Yosemite is so great, right? Because you don't really have to bushwhack. I don't know. Maybe I'm wrong. I've never done, Yosemite has two parts. It has the public part and then it has like a ton, like the majority of the park is like something you register and then you just go out with like a bag and you do your, you bring your bear spray.
You've never done it.
I've never done, you've done this.
Yeah, I do it every year.
Really?
Yeah.
What the heck? How many, do you go alone or do you go?
No, my girlfriend and I go. It's magnificent. We made a habit out of it.
Oh, double date. Another double date opportunity. We'll learn so much about each other from camping. Like I'll be unable to start a fire, unable to cook.
You're really selling yourself. As an interesting one, you're actually not allowed to bring bear spray into Yosemite.
I didn't know that.
No, so despite the bears, and I remember distinctly having the talk from the ranger before we go out, you have to bring all your food in a bear canister. So a big Tupperware looking thing that you just jar your screw top, but it's got the annoying tabs, so you have to really get a thumb in there to unscrew
Yeah, it's like
it.
airtight, right?
Well, it can't stop the scent, so instead it's kind of like a medicine bottle where you have to do some annoying, tricky thing with your fingers to get the thing open.
Yeah.
And the bears never figure it out, is the premise. And he's saying, okay, so you're sitting next to your fire, you're cooking actively, so you've got it open, it's right next to you, and a bear starts coming up, and you're like, what are you supposed to do? And you sort of, mimic the like, wave your hands above your head.
That's what you do. You scare the bear.
Well, and he says, okay, and the bear's not scared, it's still coming, it's going to get your food. What do you do? And I'm like, I don't know, like, eventually let it have the food. And he's like, no, never let it have the food.
Really?
Fight the bear. Yeah.
You're kidding.
Well, he didn't explicitly say fight the bear, but he said, no, you never let it have it. Just stand up there and hold your ground, and it'll probably leave. And if it doesn't, grab the food. And he was not having it.
But he said no bear spray either, so you can't fight the bear with bear spray.
No, because I don't want people using it. Because bears are just around, and they don't want people hurting the bears.
Just let's get close. We'll be protected because we have bear spray.
All of that stuff.
Yeah, okay.
Yep, so they don't want any of that. Yeah, no, so they're careful with it. But yeah, Yosemite's a beautiful place. Magnificent.
Yeah.
Magnificent.
And am I correct that it's
very navigable?
Yeah.
Indeed. No waterways to navigable. That is the way you typically hear the term.
All right, what do we got on the topic list?
Well, I'm wondering what experience you have with Rust these days.
I'm not a huge Rusty. My only experience with Rust is I needed to do something fast a while ago, and it was okay to do it in WASM, and I made a little Rust program, and I was very happy.
You needed to do something fast, as in you needed to develop it quickly, or was performant?
I wanted it to be performant. I was prematurely optimizing, as you do.
We love it.
Yeah, I was building an algorithm that is kind of like a weird algorithm, but I was really into this field called, I'm just going to take this topic and take it somewhere totally different. I was really interested in this very small field called truth discovery.
Okay.
And it's a mathematical field. It's very, very small. The Wikipedia page is very short.
It sounds like a show on the History Channel.
But truth discovery is basically about applying a bunch of Bayesian statistics in order to figure out from a bunch of disagreeing sources what the different truths might be, or what the truth is, or what the different truths might be, or what different truths are to different people.
Kind of secret Hitler style of there's a conflicted...
Yeah, based on all the... Yeah, and to figure out who's aligned, who believes the same thing. Who believes the same thing is really what it is. And before people are like, oh, was this for politics? Which is probably what people would assume. It wasn't at all for politics. I was running a data annotation startup, and people would disagree on labels all the time. And so I wanted to be able to run these algorithms. On any given label, we would have about 20 entries, and they would sometimes disagree.
Wow.
And what I would do is I would identify who... all the people who tended to make mistakes together, or they tended to believe something that caused them to mislabel a lot of data together, and it would help me throw out their data for specific categories. So anyway, I built a little engine for that, and it had a really cute name that I'm forgetting right now.
Open source, I imagine.
It was open source, and
Maybe this is the problem, Seve. You keep giving away everything for free.
Yeah. It hasn't worked out for me too well. No, I like open source a lot.
I love open source.
It's great. But that being said, the most successful startup I did had most of its source closed source. So I'm also not... I'm also cognizant that sometimes it's okay. Not because when you're closed source, you can really just hide things a lot better. That's honestly...
You can make worse things.
Yeah, you can make worse things. You can I don't even know how much I should say, but you're doing an API integration. It might be wrong. You don't know if you should ship it yet, but you can kind of ship it anyway, and nobody's gonna
notice.
The company you're integrating with isn't gonna find it or something. You know what? We got to cut all of this.
Oh, I feel like I might know what that's about, but we'll leave it off camera. No, the reason I ask is because Rust is starting to make its way into firmware these days, which is a really interesting one, obviously very close to the hardware side. And the safety element is a very interesting aspect of this. Now, other people have obviously spoken much more deeply about Rust, but specifically in an embedding context, it's funny because at some point you just have to write to a register, right, on a microcontroller.
Sure.
It's at a fixed address. You're literally given a number in the data sheet and they're like, stick these bits in this register. And so at some point you do have to get unsafe with things still.
Yeah, absolutely.
But it's an interesting way to go. Well, if you can prove out your drivers, right, which contain the unsafe direct access code, then everything else can be relatively safe about what you're doing.
Sure.
Which is nice because in an embedded context, it's a little gnarly to debug.
Yeah, I guess that's the nice thing about Rust is like you can have safe code mixed with unsafe code, whereas like with everything else, it's like you have to choose one. Like you use a dynamic language, you're choosing to be safe, I think. Although that's kind of arguable too.
Yeah, I was going to say, well, you're just pushing all your problems over to operational, in operation or in product in the case of embedded stuff.
Yeah, and in embedded stuff, it's not, I mean, you were talking about how in safety applications, a lot of times you're not allowed to use something that's not real time, right? And dynamic languages aren't usually real time.
No.
I don't think are they ever real time?
I'm trying to think of one that is. Well, I mean, typically dynamically typed languages, typically dynamically typed languages are garbage collected because you don't know enough about the objects it's typically interpreter time. And so you've got all these large memory allocations and deallocations happening from the perspective of your program practically randomly.
Yeah, and that can lead to, for example, in a safety context, a millisecond or 100 milliseconds can matter a lot.
Have you ever seen the video of what happens if your airbag goes off 50 milliseconds late?
No.
So to put this into perspective, 50 milliseconds is 1/20th of a second, right? It's each frame on an old movie was 24 frames a second, but about one of these. One frame on a movie that you don't even see or perceive. So in a car crash, if your airbag goes off 50 milliseconds too late, there's this great video I saw once upon a time. You crash, you're slowly, slow motion video, you're slowly leaning forward, seatbelt's sort of starting to catch you, doing wonders. And then if the airbag goes off too late, your face is already in front of the thing as the explosive goes off and pop goes the weasel. Yeah. So this is a watermelon they did for this demo, to be very clear, but the watermelon explodes.
Yeah.
And it's terrifying. And this is not to dissuade anyone from trusting airbags. You should trust them because of real-time software.
Right.
They do not go off 50 milliseconds late. And even if they 1 in a million do, you're still better off being that 999,000.
Yeah.
999 to be precise.
All right, I'll put my airbags back in. Jeez. So all of these are probably written in C and stuff like that.
Almost exclusively for firmware. Almost. There's some C++.
So what are there like unique challenges? Like I see Rust as strictly being better than C. It's just more complicated, I guess. But like, is that how people see it? Are people seeing the additional complexity of Rust adding additional safety concerns? Like just the fact that you can do more means maybe people will misuse it in a weird way?
That's a good question. I don't know. Because you can accidentally in Rust blow up your program size by accepting. So if you're familiar with Rust, you can have an enum type as an input to something, and then they're basically equivalent to an option in C, where you overlay the memory in C, or you're pointing to something that's a union is actually what I should say in C. Whereas in what happens at compile time in Rust, it says this is actually the input to this function is actually one of these three types. It's a string and it's an int or it's a float. And at compile time, it'll split that up into three functions and automatically route the correct
interesting.
calls around.
So your one function is going to become a bunch of functions.
Yeah. And that's okay because there's guarantees. It's deterministic. It's highly reliable. So I'm not worried about it misrouting it or something. But even if the right things end up the right place, your program could be larger than you're expecting, for example. And so in an embedded context, that could be a problem. Yeah,
especially in the world of like OTA, like over-the-air updates, like if you accidentally balloon the program, I mean, programs always get larger over time. It's very rare that an OTA update will
be smaller than the last.
Make something smaller. There was even that lawsuit against Apple forever ago where they were like sued because their software updates were making phones slower and their battery life go down. And Apple was just like, we're developing our software normally. Like software gets bigger over time and it almost never shrinks.
Yeah.
Which is why some people try to burn the world down, introduce a new OS or whatever. They're like, this is all
We're
junk.
starting from scratch.
Yeah.
What about Haskell? OCaml? Have you ever used either?
I've heard a lot about them. I think my perspective on Haskell, I've written a little bit of Haskell.
Oh, yeah? Okay.
I haven't written OCaml. My perspective on them is they're great to learn as a programmer because it stretches your brain. And it's really, really good to know. It gave me such a good appreciation for functional languages and as a result, declarative languages as well. But it's not the best for working with groups of people. You'll tend to get pretty opinionated.
Yes.
Because there's not as many conventions. Like there are so many books written on how to write C code and stuff like that. And when I'm collaborating with people, one of the things that bothers a lot of people who work with me, but it's probably the most valuable thing I've learned, is that it's really, really easy to give reviews of things when you can just give a name to what people need to do or what they're doing wrong. If you know the name of an anti-pattern, if you know the name of sort of like a reference section of a book, then you can give that review so much easier, and you can force the team into conventions. Yeah, you can send links. You can give it a lot more credibility. Like I could explain to someone that having in a SQL context, a polymorphic foreign key, which is an ID that points to many tables, basically. I can explain that that's bad, abstractly. I can say, oh, if you have an ID that has many tables, blah, 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 blah. And then they have to evaluate that argument. Or I can just be like, this is a polymorphic foreign key, send them a link. And all of a sudden they think they've done something atrocious, right? And
the other thing that comes to mind, a positive case, is codifying these types of things. I'm sure you're familiar with Semver.org.
What's it called?
Semver.org.
Yeah. Semver.org. Yeah.
Very
the
simple
Semantic
document.
Versioning specification, right?
Yep. Shout out to Tom, one of the co-founders of GitHub.
Oh, no way. He made that.
He at least wrote it down. I don't know if I just genuinely don't know.
Did you know I released a Semver competitor?
You have mentioned this.
Pragmatic. You mentioned it a lot, actually. Pragmatic versioning. Check it out, everybody.
Yeah, pragmatic versioning. But it's one of those things that if you say, no, we use semantic versioning on this, and then you send them semver.org, again, shout out to Tom, you send it. And it's,
they're not going to fight that.
No.
They would have to fight it with a whole page. They don't have enough ammo.
You know how hard it is to get a 6-letter .org domain?
That's true. I don't think I was able to get, I wanted pever.org.
Pever.
And I wasn't able to get it.
PVAR?
PVER, yeah.
Okay.
Pever.
What? Oh, for
like pragmatic
version.
version. I wasn't able to get it. I did get pragmaticversioning.com. Check it out.
If you can spell pragmatic.
Let me tell you something.
Go for it.
The number of versions of tscircuit we push a day is between our dependencies and the main package is like between 100 and 200 right now.
Holy crap.
Yes.
Really?
We push that many versions.
Update dependencies as soon as something's updated?
As soon as a commit comes in.
From a dependency?
From a dependency, but we're also like an ecosystem. tscircuit is made of 200 NPM modules split across 200 repos.
Oh my God.
So as soon as you merge something, it starts to go down a pipeline of releases. And so a single change can have up to 6 releases.
Wow.
And this is why Semver was never a good option for us, because the style of working is really, really great. Like you can see through the testing where something breaks without slowing velocity on sub-packages. I call this like ecosystem style development. Because it's kind of how an ecosystem would naturally do it if there was no centralized authority to be like, this is a monorepo or whatever.
Yeah.
But there's a lot of advantages. There's also a ton of disadvantages.
Yeah. Like organizational overhead. You just need to manage that many repos. You need to set up the settings, that type of thing.
Yeah, and people complain about it constantly, how long it takes to get a change in or how hard it is to test package over here against package over here. But it forces strong API boundaries, which is what I like. It makes for
good contracts.
It makes good contracts.
I wonder if there's some good, have you got any good tooling to handle that many repos? Like, can you use Terraform to configure GitHub repos these days?
Yeah.
Honestly, it seems like the right tool.
So there's a thing called RenovateBot, which will automatically update dependencies for you. And we used that for a long time. Now that we want a lot more real-time updates, and it's pretty clear that NPM is not mad at us, which we were really worried about, because we're publishing like a gigabyte a day or something.
Wow.
I mean, we gotta be, right?
Yeah.
So now that we know that they're not mad at us for some reason, we're doing instant instant publishing, and that's just GitHub workflows thing on GitHub called workflow dispatch.
Yeah.
So you can dispatch from one repo to another repo.
Okay. Yeah, crazy. Wow.
Anyway, that's why I don't like semantic versioning, because every change, even a change to a dependency up there, you would have to like give it a label. You'd have to understand the consequences of your actions. And nobody knows the consequences of their actions. Nobody knows.
I'm American. You expect me to understand the consequences to my actions?
There's a great the thing that broke Semver for me. This is such a rant, but the thing
this is gonna be a 10-minute rant.
But the thing, this is my platform. I will have my time, sir. The thing that absolutely broke Semver for me, like, is it doesn't work for TypeScript.
Interesting.
And the
Why
reason
that?
is you can break types without breaking runtime behavior.
I see. So you can break the type on an API while still maintaining full backwards compatibility.
Right.
In every other circumstance.
You could, in many times, you'll improve a type. So you'll actually improve the ability for people to use it at runtime by, like, retroactively kind of adding this type head. But then you have to release it as a breaking change, even though you're like kind of doing a fix.
But it's not okay, I'm imagining this as you're accepting, like, for argument's sake, the trivial example, you're accepting an int, and then you're like, oh, actually it works for floats too, so I'm going to make this type int or float.
Right.
But you're saying that
would be broadening, but narrowing is the case where it's kind of sketchy. Like,
yeah, that makes sense. But if you're narrowing it, you're just clarifying the API.
You're clarifying the API, and that would be a breaking change to clarify the API, because downstream they would be running type checks and they would fail. You would break everybody's pipeline. So
interesting.
And I've never felt that semantic versioning was perfect. I feel like it's better than anything else because people were crazy. If you've ever seen sentimental versioning.
Yeah, I have. You've also...
Yeah, all right. We've already done the version. Matt's like, dude, you can't have 2 podcast episodes about versioning.
I mean, I think it's 4 or 5 of this.
Oh my God. It would be so funny if we just like 2x'd, like... Anyway, but
so overall though, that ecosystem style of yours, it seems pretty highly productive.
It's good. It's also, there's also faux productivity, right? You releasing 6 versions doesn't mean
no, it doesn't. But I'm observing the cadence at which you guys are shipping features as the productivity, not based on the fact that you're saying 6 releases or 200 releases a day. I think overall you said.
Yeah, it's a lot.
Because you release every commit, you're saying.
Every merge.
Okay.
Yeah.
Yes.
So every PR that gets merged. And it all just flows into, like, we're so testing heavy, even if it's a regression test, like even a snapshot test. So it's just crazy testing heavy. And then those API things, the API contracts are so sacred. So yeah, I don't know. I think it works, but this is the 2 things that people get mad at me for are the ecosystem style development, which I try to even put into, when we're closed source. I liked that style of development. And then yeah, bringing out like a random name. I was saying, this one I should have gotten in more trouble for, but I got away with it for a long time. But I used to say London test-driven development.
London test-driven development.
Yeah, I used to say this all the time.
Okay, what's the London bit of
So
it?
Chicago test-driven development is a real thing.
Okay.
And it refers to like unit test style bottoms up. And so you do unit tests and then you do integration and stuff like that. And you should have a lot of unit tests.
And and it's test-driven development as well. So you start with writing a whole bunch of unit tests.
Yeah.
Which is an interesting place to start because it's kind of the middle of test-driven development in a sense.
Yeah.
That if you're trying to drive test-driven development is driving your development based on having a test case written against it. But you kind of imagine you start with like high level and work to low.
Yeah, and so that's what I was calling London test-driven development. And the reason I did that was very perverse. It was because I didn't want people to know what it was right away. I wanted to add credibility to it because if you say like top-down development, that's instantly understandable and they'll think of arguments against it.
Yes.
But I could link to articles about...
They have to Google it first.
They have to Google it, and then there's a couple articles on London.
Did you make
I did not make the articles,
Okay.
although I should have. I should have
Yeah,
written
you
some
can
so
see
that I
this.
was top of the result. That'd be pretty funny. But yeah, top-down development. There's also a thing called trophy style. That's another way to say it.
Okay.
So that's good and confusing to people as well. If you want to confuse your fellow developers to get unfair leverage like me. Trophy is where you have integration tests. Kind of a trophy shape. Doesn't make a lot of sense because like, I don't know what kind of trophy shapes you got growing up, but mine were always very strangely shaped. Like it'd be a hockey stick, you know? I don't know. But
I never played hockey myself, so.
never played hockey.
No.
Australia, they don't have a lot of hockey.
No, not so much. I mean, it happens. Not so much ice hockey for sure.
I feel like ice hockey is so different than roller hockey.
What
Is that
about
what they
field
have?
hockey? People play
Yeah,
field,
field hockey is quite different too.
Yeah.
Like they're all great sports.
Yeah. I had some friends that played field hockey, but that's a very distinctly different sport.
Yeah, very different. Yeah, and I was always like really bad at roller skating too, so I never liked it when people were like, "Oh,
Ice skating?
no, ice skating, great."
You were playing field hockey.
No, I was doing. Wait, so okay, I got to get my
Field
terms in
hockey's you're running.
it. Field hockey, you're running. It's
Yeah.
on grass too, right?
Yeah.
Yeah. It's different than lacrosse, right?
Yes. You don't get a scoop.
Lacrosse is a hockey for grass. I don't know what this field
when I
hockey
think of
thing
field
is.
hockey, actually, I think, you know what? It might have been like tennis surface.
What's it called?
Like, no, like a tennis court. I think, I was like, if I'm trying to remember correctly, I think that the field hockey and the tennis courts were the same and they just moved the nets.
I got to
look
look
it
up
up.
field hockey. I have no idea. We'll go into this next step.
And yep, and the next time on Electronics Dev, we will look it up.
All right, what else do we have on our topics list? Let's get back to electronics.
Well, the reason I asked about the OCaml and Haskell is because there are a couple of development pipelines to create or to develop for FPGAs using
No way.
Haskell and OCaml,
I love it.
which is really cool. So, I mean, TLDR in the functional programming is you basically, for practical purposes, you end up setting up a pipeline and then shoving data through that pipe is like one way of thinking. Or like you end up setting like almost like a processing line and then you shove data in the pipe or right down the line and it gets processed as it goes.
I think what I've always liked people saying is in imperative programming languages, you tell the computer what to do. And in functional programming languages, you tell the computer what you want, right? So you focus on the definition of a computation rather than what variables you need to define and stuff like that, and where registers are going to go and stuff like that.
Yeah, it's a very confusing concept to describe, but if you think of it in this like sort of functional pipeline-y sense, it kind of makes sense for FPGAs because all of a sudden, if you're building a processing pipeline of you're just like you can imagine, you are ingesting subsignal at a high frequency, and then you are. So you've got some ADC, you're slamming the bytes out of that. You're then moving those bytes into RAM. And then when some trigger hits, you shuffle them all out to the processor as quickly as possible. For argument's sake, right? This would be for like an oscilloscope kind of pipeline.
Sure.
So something certainly to check out. HardCaml is actually from Jane Street.
HardCaml.
HardCaml is what that one's called. It's actually from Jane. You know Jane Street?
Jane Street, it's like financial stuff, right?
Exactly.
So they want to do some fast trading.
They want to do some
That's
fast.
funny.
Yeah, you got it.
This reminds me of Bloomberg had like a JS runtime before anybody else had a JS runtime.
No way.
Yeah.
Oh, wow. There you go. I mean,
I remember them recruiting for it. They were like, yeah, we have a JavaScript runtime. And I think it might have been open source too, but it never took off. I don't think.
Yeah, it makes sense. I mean, they're out there like cranking money, so they do not care about maintaining compatibility for anyone else.
Yeah. And also like their concerns are just so different. Like in the JavaScript land, we care about so many like frivolous things.
Like supporting Internet Explorer.
Maybe I'm almost thinking like, I don't know, like Bun, which is a JavaScript runtime, like built-in support for SQLite and I think even Postgres. So they just like are adding fancy things on, and then I'm like, oh, great. I don't know. Cool.
Yeah, just today, I was actually embedding for the first time in many, many years, SQLite or SQLite into an application, an embedded application in this case.
Hell yeah.
In Rust, and it's async, so multitask can access simultaneously. If you just want a store on disk that you, in this case, on disk, in application that you can update incrementally for things as they come. It's future proof because you just have migration set up. It's like, it's actually kind of hard to find something better.
Yeah. SQLite is great. It's hardened. I don't know if we already talked about this, but do you know how the SQLite guys like how they prevent like forks?
No. Oh, I know. Their testing is closed.
Their testing's closed. We probably talked about it.
No, I've heard it elsewhere because it's one of the interesting cases of a fairly successful open source project's monetization.
Yeah.
It's a really complex C program, right? Like this is a whole database in application, and it's tiny. Compiled. I mean, it's tiny in some sense. It's enormous in another.
Yeah. I don't know if there's like a ton of content on SQLite, but the story is like super interesting because they're all very religious.
Are they?
And I mean, yeah, I think so.
They're American, I assume.
It's some American religion.
Are they Mormons?
But I don't know what it is, and I don't want to like mislabel it.
Yeah.
And originally the software was built for like Navy destroyers, but or something like that, like boats. Like they needed a database for these very serious applications
To check who touched the boats, and then you.
Yes. But I think one of the reasons they were getting forked is people were saying that they were a little bit insular.
Insular, yeah.
So people were like, you're not like if you're not part of their little. I think of them as like a monastery. You know how monasteries used to like copy Bibles and stuff like that?
Yeah.
They were like doing like really tough labor inside and producing this output, and they didn't really care about whatever else.
Yeah, I'm just imagining you opening up the SQLite website, which I did today, and just hear this like HaLow, like, oh.
HaLow was a great game, by the way.
Fantastic game.
Oh, man.
So the insular monks building SQLite, it's officially recommended by the Library of Congress, I read today.
That's right.
As a storage format, and they plan to make no API breaking changes until 2050 is their explicit plan, which they've been around 35, 40 years or something already, possibly more. It's an old piece of software. And so you actually believe them. They only got 25 years left.
Absolutely. And they're so central to so many things. Like you would never know all the things they're embedded in. I know a lot of apps use it as like a message passing channel. It's just like it's just such a solid way to store things. It's like more solid than your file system, basically.
Yeah, it's incredible.
SQLite, love it.
Yeah. Shout out SQLite.
Shout out SQLite.
Oh, you're losing me a second there, but on the Jane Street, the high performance stuff. Oh, yes. And you can actually compile down through all of these. I think part of their synthesis is they actually go via VHDL or Verilog. I can't remember which means you can actually use them to design chips as well.
Hell yeah.
Which my money says Jane Street was probably doing.
Yeah, for sure. It's so interesting because, it's crazy VHDL and Verilog haven't been like truly replaced. Like, what is the higher level language most people use above these things? I don't think there's...
No, they're still the dominant. It's kind of like asking, it's amazing how C hasn't been replaced.
Yeah.
What's the higher level language? Or even assembly. I was looking at these stats the other day, and whichever of these coding indices of how much they used had assembly at 1% and Rust at 1 as well. It was like 1 point something. And assembly was actually just marginally higher than Rust still.
Really?
In terms of the code volume, which actually, I'm not sure if it's per total existing or per year, but it was, I'm sure you've seen the FFmpeg Twitter account. They posted it because they're like, suck it, you Rust stations. Yeah. It's our hyper optimized assembly code that's doing this.
Wow.
Yeah. So incredible stuff.
I wonder if LLMs will make it so that, we've talked about this in the past, but if there will be a great freezing and maybe we'll be having assembly written forever, there won't be a need. Like how many higher level paradigms can you just skip now? I think the time of inventing languages is over. That's my thought. There's not going to be another language.
There's not going to be another language. Okay.
It's over.
I'm skeptical about that for the reason that I think that if you come up with high level languages are just creating different abstractions. Typically, most of them share a lot or most of these abstractions, right? Because we've come up with some really effective ones that suit our brain architecture well.
Sure.
We're good at abstracting problems in specific ways, and some problems lend to being abstracted in some ways better than others. Functional imperative, for example. And so I think that when the LLMs, AI, and whatever flavor they come in the future are able to trivially spin new compilers, because for them it's just a snap of the fingers, they've created a new language, will it not benefit them sufficiently to just create an abstraction that suits their application, their niche really well?
You're not wrong. I think there's two theories of the universe right now. This is great. Yeah, this is great. Okay, so there's two theories of the universe right now. And I would say even the dominant theory is that there's going to be a ton of new DSLs for interacting with the physical world. I saw, or building things in the physical world forever. So there are two examples. One is, I saw a robot that was like doing a factory task, and they had invented a DSL around moving the arm and pick up this and whatever. And so, yes, it's very easy to create those DSLs now. And the other example that I think is huge is Atom CAD, this funded startup that has kind of a studio where you use AI to create CAD, and they have their own CAD kernel and their own CAD language, and so they've created this DSL. And then you can see that OpenAI is investing in this. They have built-in support for this Starlark thing. So you can now send your Starlark schema. Starlark is like a way of defining new languages. So you can send this schema to OpenAI, and it will output in your language. So if you have a Starlark grammar, then you can have OpenAI output in your language.
That's okay. So Starlark, is it some reuse or maybe a homophone of the name? Because Starlark is Google's language for Bazel as well.
Oh, is it?
Yeah. So the Bazel build system, Starlark, is a Python derivative that actually also has a very good open source Rust implementation, and our good friends over at Diode use as their foundational language.
Oh, is it not a grammar?
Well, I mean, I guess there's some grammar behind it, but it's actually perfectly compatible with Python in the sense that you can run or it's a subset of Python such that you can run Starlark in a Python interpreter. But you could plausibly define extra parts of it, or you're saying in this case use Starlark itself to define a language schema?
Yeah, I saw something from OpenAI. We can dig into this more in the next episode. But we've decided to dig into things more in the next episode when I'm clearly uninformed on them.
Well, we're both horrifically uninformed. So,
but yeah, OpenAI has, I believe they announced some kind of direct support for outputting DSL. So anyway, this is one vision of the world, is that AI will write in DSLs. And then the more niche-y vision, the one that I'm a big believer in, is AI will write TypeScript. The one true language has already come.
You are a prophet. And here you are calling the SQLite guys insular religious folks.
Yeah, I'm like a branch of that religion. No, I think it's a legitimate religion, so I don't want to say too much. They're good guys. I respect them. I really think like there's a place in the world for companies that operate like monasteries. Like they're like, you will not get rich, but you will find peace. By the way, there's no peace at, my companies, as everybody knows. So it's complete chaos. So I am not a monastery, just to set it straight, but I believe that they're great.
Well, you're open source. You put it out all in public. You sound closer to a Quaker than a...
Yeah, I'm still spreading. I'm more of like one of I don't want to say anything controversial, but I'm more of a religion that would get out there, try to spread itself, convert people, stuff like that. I'm more of like a, like the spread one rather than the closed cult.
Yeah, I could pick some religions, but maybe we just close it off there and avoid offending any of our dear friends.
What's up with all this? This is what happens when we record late night. What else do we have on the topic list? Do we have any more?
I've got one more topic. Have you ever come across Wi-Fi HaLow?
Wi-Fi HaLow? I've never heard of this.
It's a Wi-Fi standard that came out about 5 years ago, but it's only really starting to pick up. It's based on the 900 meg spectrum. The unlicensed 900 meg band, as opposed to 2.4 is typically the next lowest frequency for Wi-Fi to run at. So it's got lower bandwidth, lower power, but significantly more range. It's really cool.
Okay. So with Wi-Fi, I've got 2.4 gigahertz. Everybody knows that. That's old. 5 gigahertz.
Old, robust. looked after.
Looked after.
Yeah.
It maybe 2.4 maybe goes a little further.
Mm-hmm.
Is that all in my head?
It does go further. It does
It does go
indeed.
further.
Significantly.
Okay, great.
Yep.
Significantly? I did not know that. 5G is what I want my TV hooked up to. So for my 4K streaming, right? And then,
5 gigahertz Wi-Fi, that is, you mean?
Yeah, 5 gigahertz Wi-Fi.
You could also get a 5G NIC and SIM card for your TV and connect it to the cellular network 5G instead.
Oh, shoot. You're right.
Well, you said 5G, so I'm just clarifying for everyone
Oh,
listening.
that's interesting. Yeah, that's confusing.
Which is actually amazing that the cellular internet in most Western countries is faster than the wired internet.
Yeah.
In a typical case.
Have you ever gone to somewhere that has like 3G, 4G? I was somewhere where I got 4G LTE, which back in the day felt like the fastest thing in the world.
They've been derating it. It got worse.
So it got worse.
We do not misremember. It got worse.
What? What?
Yeah, unfortunate. I'm conspiratorial, so I do, at least to some degree, believe they've intentionally been nerfing it to force you to move over to 5G so they don't have to maintain it.
Matt, you're not walking home alone tonight, are you?
Yeah.
So you're saying,
Big
who's
telecom.
doing this? Who's behind this? Who's behind downgrading 4G LTE?
Well, in my opinion, probably at least to some degree, the carriers.
So we're talking about Verizon.
Yeah, Verizon, AT&T, Comcast have anything
This
to
guy
do
has
with
no
the US?
fear.
Yeah, come
There
at
goes
me.
my sponsorship, by the way. I
Oh,
was about
I'm
to announce
sorry.
it. Verizon. What's their like slogan thing? Verizon, can you hear
Screw
me?
you, give us more money.
Screw you, give us more money. Verizon. I've been a Verizon customer for my whole life. I think I've always had Verizon.
Wow. Okay. I
So I
tried
don't
to
know.
switch out, and turns out the startup mobile provider actually just got bought by Verizon. So now I'm
Really?
back under Verizon, whether I like it or not.
Welcome back.
Please don't cut off my internet. But no, Wi-Fi HaLow, very interesting new standard, because we don't actually have any normal consumer carrying device. Like your phone currently and your laptop don't have a 900 meg antenna on them.
Yeah.
But some really interesting applications. You can imagine if you had slow home internet connectivity, Wi-Fi connectivity, whether or not you had cellular, a kilometer from your home even, plausibly.
Yeah.
Or you have low power IoT devices actually on a home Wi-Fi network.
So this is gonna kind of mess up LoRa, right? So everybody's using LoRa for long range.
Yes.
This is an attack on LoRa.
Well, to some degree, but it does edge in that direction. But LoRa is lower power and longer range at the trade-off of a significantly lower data rate.
Oh, okay. So Wi-Fi HaLow is not making the trade-off on data rate. It's like,
Well, it's slower than 2.4, but you can still stream video over it at a couple of megabits.
and how far did you say it goes? This Wi-Fi HaLow?
Kilometers.
Kilometers.
I mean, like in a typical
Super far.
case, kilometer and sub, but I've seen demos out really far. And it obviously depends a lot on your antennas.
Is the antenna going to be big?
It will be longer, yeah, because it's a longer wavelength.
Are we thinking like it's going to be like 900 over 2.4K, like bigger? Like is that the right assumption?
Yes, for an equivalently configured antenna. There was a video by a YouTube channel called Data Slayer, actually, that if you're interested to watch, I sent to you a few weeks ago, or in the chat a few weeks ago, where he actually sets this up as like a point-to-point radio, not dissimilar to what you can do with Meshtastic messaging.
Really?
But you can have a live video call or stream map positions and
This is going to be huge for drones, isn't it? Isn't this like perfect for drones?
It does sound perfect.
You always wonder when the standards hit when they do,
Yeah.
So with 2.4 gigahertz, the antenna, I'm trying to think like in ESP32, they have I know how big the chip antennas are. I'm thinking they're like, I don't know, not half an inch, less than half an inch, a quarter of an inch maybe.
Yeah, they have a trace antenna on there sometimes as well.
Yeah. And those would be bigger than the chip antenna, right? Like
Well, see, the thing is, you can your antenna, you can set up different properties of your antenna as long as you pick a resonance that is, a half, a quarter, an eighth, a 16th. So you can take it to, because you end up with nodes, right? If you to plot out the the response to a 2.4 gig, or to any radio wave. Your response is going to basically be either you can have a half wave antenna and that will oscillate correctly one half of the wavelength that is as the length of the antenna. So when I say a half wave, you can do a quarter, you can do an eighth, you can do a 16th, and they decay in their gain, but they still will resonate much more than just some random piece of wire.
Very interesting. Okay, so you're kind of taking some sacrifices as you give up size.
You do.
Those ESP, these little ESP32 modules that everybody knows with their PCB antenna, do you know how much of the wavelength they are? Like what compromise have they taken there?
Well, if I remember very off the top of my head, I want to say a 2.4 gig antenna's wavelength is something like 12 centimeters.
Okay.
Now, this has been a long time since, in fact, I was literally a 14, 15-year-old last time I did this for drones that we would home build back in the day. But 12 centimeters, so that's actually exactly 1/10 of a foot, if that's how you guys do your...
Matt, you act like Americans love the imperial units. We're born with it. We're taught it for 16 years. All of a sudden we encounter something from Europe and it's a new unit. And yes, it makes more sense, but we just don't have the intuition. Anyway.
Well, I do the conversions for your intuition's sake. I'm merely trying...
But you do it with such disdain, Matt. You roll your eyes, you go, I guess 1/10 of a foot. No, I kid, you're great. And I appreciate it because I never know what you're talking about. 12 centimeters.
It's about a hamburger width.
Oh, it's a hamburger. Oh, yeah. Wait, are we talking to McDonald's or not?
McDonald's.
An Arby's? Yeah,
McDonald's. Diameter.
No, I'm with you. Double. I always double. So double patty. What's that?
No, diameter. No, round. You're looking top down.
No, I don't even know. No, I don't know. You got to make that clear. You got to make it clear. Just say a quarter pounder. Quarter pounder bite part. I don't know what I'm talking about.
Okay, so going back to the mathematical.
So what is it? Is it a half wave antenna? Is it a quarter wave? I think it's probably a quarter.
A half wave whip, if I remember correctly, is about 12 centimeters.
Yeah.
So and then
a half wave is 12.
If I remember, again, I'm not calculating this. I'm just trying to.
It's going to be like a 16th probably. Take your guesses. Leave your guess in the comments.
I would guess a 16th off the cuff. I reckon you're probably right. And that means that, with a 900 meg antenna, it's going to be, approximately 3 times the length, 3 times the size for a given fraction of the wave. So they're going to be bigger antennas, but it would be a really cool thing that we could stream this all around live. As you say, drones. I mean, imagine if your phone had a 900 meg hookup in it, you wouldn't need the DJI radio anymore to fly a drone a kilometer away, live stream video, and controls reliably.
Yeah.
Which is pretty rad, I think.
Yeah, for sure. And speaking of news that we probably haven't researched too well, but
Is that the new segment title? News that I saw and I will now confidently relate.
I hesitate to even say anything because I know it's a meme. There's like TikToks about podcast bros not knowing their topics. But anyway.
Or if someone started making memes about me, I'd be pretty happy.
Yeah, I wouldn't mind being on a popular meme just once, have my 5 minutes of fame. But I think Starlink? Is that the guy? I think it's coming to cell phones. Have you heard this?
It is. I haven't.
How does that even happen? How does that happen?
It's amazing. So, I mean, they basically just put practically a cell tower up on the satellite and point it straight down with a wild gain antenna and high power.
So it's literally so there's really not anything clever going on. They just put a cell tower.
I'm sure they're pretty clever. I'm certain they're clever.
But it's funny that nobody considered that an easier solution than building cell towers. Well, I guess at the time cell towers were built.
Hang on. So you have to put for this to work, it has to be in low Earth orbit, right? Okay. Because they're still 100 Ks away, 120, I want to say, off the cuff, which is really far.
Than a cell tower.
Much further.
Oh, it's much further.
Yeah. It's like a modern. So the thing is, 3G, you would have a 20 kilometer link to your cell tower, and that would be okay.
Okay.
Right, 4G didn't really work anymore. It was probably at a guess,
so
10.
They had to put up a ton of cell towers for 4G.
Yes, and it's area as well. Yeah, you have to imagine again, like if your radius, your distance to the tower is limited, is halved, right? The area that each tower can cover has quartered. So you have to put up 4 times as many towers, right? And then with 5G, it's really close. It's really small. Like there's towers everywhere. But for argument's sake, say the longer range mode of this, which is better. There are a few modes. There's a high speed mode and a high data rate mode and a longer range mode. But for argument's sake, say it's like 5K range to the tower now for the higher frequencies of 5G. It might be longer, but then you've halved it again. So it's an 8. You need 8 times as many towers. 16 times as many towers as the original.
Yeah, so that's pretty crazy.
So I don't know exactly what they're doing with the Starlink internet, but if it's 120 k's away, you can imagine how much power they're going to be cranking on the satellite and how much gain their antennas are going to need to have for them to receive the signal back from this, which is just a tweet in the dark.
Mind-boggling.
It's incredible.
Wow. And I guess you also need a lot of satellites because the
Ding, ding, ding.
area,
Yes.
it's pretty small.
So it's not just the gain in that, but the real challenge I think is if you set up an antenna with that much gain and that much power, you need thousands of the things to be that close into Earth, because otherwise if you put them in geosynchronous orbit, like historically, or I don't actually know if it was geosync, but for satellite phones significantly further away, whether it was 34,000 kilometers or somewhere in between, you need fewer satellites, but getting cellular communication,
I'm imagining
that's crazy.
Whoever was setting up cell towers, somebody would propose, why don't we put up a satellite? And they would laugh at it because you would need they'd be like, okay, you'll need a rocket program. And then that rocket program will need to be able to bring up this many things.
You'll need like 100 satellites on each rocket.
You'll need 100 satellites in each rocket, and you'll have to have a rocket going up like daily.
Yes.
And then somehow that happened.
Yep.
It's actually crazy. It's crazy.
Crazy impressive.
But,
what a world we live in.
Yeah, what a world. What a world.
Seve, thank you very much.
See you next time, Matt.